Okay, just so we're aware here, guys. Okay, this rock is thrown at an angle into the air. Okay, so it is following a projectile arc. Okay, where the launch point and landing point are at the same height. Okay, so there's no change there. Right, and all we know is that it travels horizontally 30 meters in 10 seconds. We don't know this angle, and we are looking for this. The velocity it was thrown at, that would include this angle. Okay, so we're looking for this and the angle. Okay, so the key to this one, okay, is that we can find at least one side of this triangle, okay, and it's this side, okay, with just the information we've been given. Okay, we know that it travels horizontally 30 meters in 10 seconds. So if we're doing what we always do, okay, with a projectile motion question, we're writing our horizontal information, d equals 30 meters, okay, t equals 10 seconds, okay, and our vertical information. Right, so vertical information is, I know the acceleration. It's negative 9.81 meters per second squared, and that's it. That's all I know. Okay. I also know the time, sorry, 10 seconds. All right, so I know those two things. So I can find V horizontal right now by doing this, just going 30 over 10. Okay, so the horizontal component is 3 meters per second. All right, so V horizontal is 3.0 meters per second. So I know that, okay? Now, here's the other thing that I kind of have to remember, and that is that if something is launched and lands at the same height, VI equals VF, negative, right? So VI equals negative VF, right? That's true as long as it's launched and lands at the same height, and that's why I kind of made a big deal out of telling you that. So here's what I have to understand then. I have a formula that has these four things in it. It's A equals VF minus VI over T. But we look at that formula and right away go, I can't use it. I don't know either one of the V's. But it doesn't matter because they're not what? They're not different. They're the same number. So what I can really say is that A equals negative VI minus VI. Because that's what VF is, right? It's VI, but it's negative over time. Well, now I've got VI in here twice. What's negative VI minus VI? Negative 2 VI. Now, I have a formula that only has 3 things in it, and I know 2 of them. Now I can find out what VI is. And you're probably going, so how does that help me? I'm so lost. Okay, well, here's how it helps me. It's this side of the triangle. If I know this side of the triangle and this side of the triangle, can I find the hypotenuse and the angle? That's why I need it. Okay, so this is really recognizing an important physics concept, VI and VF are equal but opposite, but also a bit of a math trick, okay? In that I have to recognize that since these two numbers are equal, I have to write that formula like this, and then I can isolate for VI. Okay? So now I'll isolate for VI. I'll have A times T, okay, divided by negative 2 equals VI. Right? So that'll be negative 9.81 times 10 seconds divided by negative 2. Okay, everybody all right with that? All right, so negative 9.81 times 10 is going to be negative 98.1. Divide that by negative 2 and you get 49.05 meters per second. This thing's fired almost. Okay, yes, very fast, but also almost straight up. I mean, think about it. This side of the triangle is 3 meters per second. This side of the triangle is 49.05 meters per second. Okay, this thing is thrown almost straight up in the air at, well, a speed you could never throw a rocket. even a major league pitcher would be pretty hard pressed to throw something that fast. Okay, so those are my numbers. Now I can calculate what this side of the triangle and this angle are using Pythagorean theorem and trig. It's backwards, right? Most of the time we're using that number to get V horizontal and VI and calculate time and distance. In this question, we were given all those things that we're normally looking for and asked to work backwards. Okay, so it's a little different, a little bit trickier because we hadn't seen one like that. But in fact, it's still the same set of steps, just like I say, done in reverse. Okay, so I would find the hypotenuse of that triangle, okay, by going 49.05 squared plus 3 squared. Okay, so we're looking at 49 meters per second. Okay, and then we'd find the angle, okay, second tan of the opposite side, 49.05, divided by the adjacent side, 3. Okay, and this thing is shot at 87 degrees above the horizontal, so almost straight up. All right, so that one's a little different, a little tricky. All right. Now, you guys had one like this on your projectile motion worksheet. Okay, so I want to have you guys try this one because I don't think we've done this one in class. Okay, so what we have in this one is a ball that's rolling off, this should say a decline, okay? But it's rolling off like this. So here's the kind of the top of the building or the, off of a table or whatever it is. So the ball is up here and the ball is going to roll off of here, okay? It lands 1.4 meters from the incline. So they're telling us, okay, this horizontal distance. Okay. And we know that it rolls off at 12 meters per second. And we know that the incline is 30 degrees. So that means that the decline is also 30 degrees. Okay, so how is this one similar to what we've been doing? Right, the horizontal and vertical parts are still part of this triangle. This is still VI, this is still V horizontal. What's different? Yeah, VI will be negative this time, and VF will not equal VI. It's not going up and down to the same height, it's going off the building. Right? So now VI is not the same. Okay? So from a vertical perspective and a horizontal perspective, you got to work out what you have and then see if you can solve for effectively the vertical displacement. Okay? How tall is the, how high above the ground is the end of the incline? Okay? So you're looking for this right here. Okay? Give you a few minutes on that one. All right, so if we're solving for this one here, okay, we first need to find VI and V horizontal. Okay, we do that our usual way. VI will be the sine of 30 degrees times 12 meters per second. So it's going to be negative 6.0 meters per second. Actually, we don't need the negative there because it never goes upwards. Okay, our acceleration is 9.81 meters per second squared. Okay, V horizontal is going to be the cos of 30 degrees. A times 12, so we're looking at 10.392 meters per second there. Okay. So now what I want to do is I want to try and find my time because I know also the horizontal distance is 1.4 meters. Okay. Knowing that, I can now calculate T. T equals D over V. Okay, so that's going to be 1.4 divided by 10.392. So obviously the time is going to be very small. Okay, so 1.4 divided by our answer there, and it gives us 0.1347 seconds. Okay, so I can go back over here. Time equals 0.1347 seconds, right? And I'm looking for D. Now I can find that using this formula. D equals VI times T plus 1/2 AT squared. I don't have to manipulate it. I just plug in my numbers, right? So I'm going to have 6 times my time plus 0.5 times 9.81 times my time squared. Right? So this table or incline or whatever it is 90 centimeters above the ground. Okay, or 0.90 meters above the ground. Everybody all right with that? Okay. So these are just a couple that are a little different than the ones we've been doing, because the ones we've been doing have been pretty cookbook. They're all pretty much the same. As long as you follow the recipe, you're all right. They don't make you think outside the box too much. Okay. Now, that said, on the test, I'm probably not going to give you the hardest, trickiest one that I can think of. Okay. I'm probably going to give you something more along the lines of the cookbook ones that are showing me you know how to do a projectile motion problem. So keep that in mind for tomorrow. Okay. Now, in terms of tomorrow, okay, so for number 11 here, we've got it thrown into the air at an angle of 30 degrees. Okay, to the horizontal. The object reaches a maximum height of 5.75 meters. How fast is it going there? 0, right, okay? We have to remember that if we're going to solve this problem, okay? Is that VF at its maximum height is 5.75 meters per second. So we're still looking for what velocity it was thrown at. We know the angle already, okay? We just have to find out what this side is. Well, we can do that with just either the horizontal velocity or the initial vertical velocity. Which one of those can I find with the information I'm given? I can find the initial vertical, okay? And I can do that using this. VF squared equals VI squared plus 2AD. I know D is 5.75. I know A is negative 9.81. I know VF is 0. Okay, so I can isolate VI by simply going VF squared minus 2AD, okay, square rooted to give me VI. All right, so that'll be 0 squared minus 2 times negative 9.81 times 5.75. Right? And when we do that, we get 21.2 meters per second at 30 degrees, okay, above horizontal. Okay, everybody with me there? Right. Any of the other ones giving us trouble so far that we need to go over? Don't be afraid to ask. Okay, keep going on them. All right, so 16 is another one that's a little bit different. It's projected off the top of a building at an angle of 28 degrees. That's actually above the horizontal. Okay, so we've got the top of a building and this thing is getting projected like this. Okay, so this angle is 28 degrees. Okay, the velocity is 15 meters per second and the object is going to hit the ground over here. Okay, about 32 meters from the base of the building. So the horizontal distance is 32 meters, okay? And we know this is 15 meters per second, okay? We're trying to find the height of the building. Well, the height of the building is going to be the overall vertical displacement of the object, agreed? Starts from the top of the building and ends on the ground below the building. So yeah, it's going to go up and come back down, but in the end, its overall displacement is from the top of the building to the bottom of the building. Okay, so that's one of those spots where remembering the definition of displacement comes in handy. Okay, remember I said you got to make sure you go through your notes. This is one of those reasons where, I got to remember what the definition of displacement is. Okay, I can also find VI. I'm going to need that. Okay, so that's going to be the sine of 28 times 15. Whoops, it's got to be on. Sine of 28 times 15. Okay, so we got 7.04 meters per second. And that'll be positive. Will VF be equal to VI in this situation? No, it will not. Okay, so I don't know what VI is, but I do know what the acceleration is. It's negative 9.81 meters per second. Okay, can I still calculate the horizontal velocity? Okay. I'm going to calculate V horizontal by going cos of 28 times 15 meters per second. All right, so we're looking at 13.244. What can I find now? Time. be useful? Definitely. All right, so time equals d over v, so that'll be 32 meters divided by 13.244, so we're getting like 2 point something here. Okay, so 32 divided by our answer gives us 2.416 seconds. Okay, can I find the vertical displacement now? I've got VI, A, and T. So I should be able to find the vertical displacement, which is the height of the building, using that formula. I don't even have to manipulate it. It's set up to find what I want. So this is another one that's atypical, but not really a whole lot harder, just a little bit different than the others. We still had to do all the same things. Find V horizontal, find VI vertical. Okay, all of that stuff still goes. Okay, so we've got 7.04 times 2.146 plus 1/2 times negative 9.81 times 2.146 squared. Okay, so 7.04 times our answer plus 0.5 times negative 9.81. The negative is crucial here. Okay, times our answer squared, whoops, not square root, times our answer squared. Okay, so the overall displacement is 11.6 meters, and it's negative, which makes sense because it's falling from the top of the building to the ground, although you don't want to say that your building is negative 11.6 meters tall, because that would imply the building is built underground. Okay, you would want to say that your building is 11.6 meters tall, or 12 meters in this case because we only had two significant figures. All right, so a little bit different, but still, okay, similar in terms of the calculations that had to be done for that one. Okay, how many people have done all 16? Okay, if you're done all 16, you've got that review sheet you could be working on. If you're not done all 16, then I'd like you to finish them up so that you're ready, because as I told you on Friday, there's one of each kind of projectile motion question on your unit exam tomorrow. Okay, those are pretty big marks. I think one of them is worth 6 and the other is worth 7. Okay, so they're pretty big, okay, in terms of the amount of marks they're worth on the entire test.